1.2c, dividing whole numbers. When we divide whole numbers, we use long division. So division can be expressed in multiple ways. So we can write it like x divided by y. That's how that's supposed to be read. This is also x divided by y. X divided by y. And finally, this is long division. This is x divided by y. And there's a reason we write it this way rather than the other ones when we're trying to compute the actual division. It makes it a lot easier. What is left over is called the remainder. So let's go through a couple examples. Example 1. Compute 90 divided by 5. So let's write it in the long division notation. So 5 goes out front because it's doing the dividing, and 90 on the inside. We close it. So we look at the largest digit first. And how many times does our number go into this first number? Well, it goes in once, right? 5 goes into 9 once. And we subtract 5 from the first digit. We'll put a 0 as a placeholder. And what's left is 40. Now, how many times does 5 go into 40? Well, 5 times 8 is 40, so 5 goes into 40 8 times. And we subtract the 40. We have nothing left over, so there's no remainder. So that means 90 divided by 5 is 18. We can check this pretty quickly too by doing multiplication, which is the opposite of division. So let's do multiplication to check our work. 18, 5, the times symbol. 8 times 5 is 40, 0. Carry the 4 up here. So 5 times 1 is 5, plus 4 is 9. So 18 times 5 is 90, which is the same as 90 divided by 5 is 18. So we're good. Here's another example with a remainder. So compute 452 divided by 13. So again, let's write this out in long division notation. So we have 13 on the outside and 452 on the inside. So this time, instead of looking at just one number, since we have two numbers here, we have to look at the first two numbers. So how many times does 13 go into 45? Well, 13 times 2 is what, 26? 13 times 3 is 39. 39 is probably the largest we're going to get. So we can have 3 of these enter 45. So we write 39 under there. And a 0 as a placeholder, and we subtract. So 452 minus 390. We bring down the 2. The 45 minus 39 would be, what, 6? So we're left with 62. So now the question is, how many times does 13 go into 62? So over here on the side, we can kind of check how many times we might think 13 goes into 62. So we know that 13 times 3 was 39. If we added 39 together, we would get, what, 78? That's too big, so it's not 6. Minus 13, let's check, 5, 65, so it's not 5. So I think 4 is the largest it's going to go in. We can just do some multiplication to check, but let's try it out. 13 times 4, so we write a 4 here. 13 times 4 is 52. And we subtract these two numbers and we're left with 10. And we were right, 52 was the largest number that could have gone into 62, or largest multiple of 13 that could have gone into 62, because we're left with something less than 13. So since 13 can't go into 10, we're left with a remainder, so we write R10, remainder 10. So that means 13 times 34 plus 10 equals 452. And we could check this if we wanted to, but it's okay. Now let's try an application. I have a box of 475 spark plugs. How many four-cylinder engines can I replace spark plugs in? How many will I have left over? Assume each cylinder requires only one spark plug. So we have four-cylinder engines, right? And each cylinder requires one spark plug. So one engine is 4. And we need to divide into 475 because that's how many spark plugs we have. So how many engines could we fill up? So since this is a one-digit number at the front, we just look at the first number. So 4 goes into 4 once, obviously. 4 times 1 is 4. And we have zeros as placeholders. We subtract. We're left with 75. So 4 goes into 7. How many times? 1. So 1 times 4 is 40. And we're left with 35. 4 times... How many times does 4 go into 35? Well, 4 times 9 is 36, so it's got to be 8, right? 4 times 8 is 32. And we're left with 3. So we have a remainder of 3. So that means we could service potentially 118 engines, but we would have 3 spark plugs left over. So you'd probably have to make another order at that point.